State 35 is reboiler. There's a liquid leaving state 34 at the bottom. Enter the state 35 reboiler. This liquid leaving state 34. What are the temperature, pressure, flow rate? Those are internal stream, not the product stream, distillate, bottom product. So you use the concept of pseudo stream to get the information of top vapor entering the condenser. So you specify pseudo stream. You take a stream out, and then top vapor input. This, you need to go to the column. Column 1, specification. Stream. Top vapor 1, internal stream. Leaving stage 2 vapor, going to condenser, stage 1. That is the top vapor to be condensed. This is your pseudo stream. You use this, you specify heat exchanger. You must use MEK to condense this. This is a condenser. We did a condenser in file number 3. Cold stream outlet temperature, MEK coming out minus 19. You metric condenser 0.85. So, what is the MEK mass flow rate you need to condense this ACN product? You need a design spec, DS1. Here, you fully condense the top vapor, 0. VFOUT, product vapor fraction, fully condense it. Very hot, MEK inlet flow rate. Result. This is already done, the flow rate is correct. Now, this is for condenser. Let's look at another. You can follow the page-by-page instruction. In my condenser reboiler sighting handout, here. Now open up the reboiler sighting. Why do we need to size condenser reboiler? Become familiar with use of pseudo stream. And then next time when you do heat integration, the condenser, a second column at 110 degrees C. Reboiler of first column, 60-some degrees C. You can integrate both of them using pseudo stream. I will demonstrate that next week. Okay, look at this flow sheet. Here, bottom liquid. You look at this, 35, state 34, liquid go into reboiler state 35. What is that temperature, pressure, flow rate? We use a pseudo stream to specify it. You can look at the stream. Pseudo stream, liquid leaving state 34, entering reboiler state 35. It's a liquid. Okay? So, you look at the flow sheet, the way we do it, material, first one is side product, second one pseudo stream. You take one out. You add an exchanger reboiler. For the first column, use low pressure steam. Input 172 kPa, vapor pressure 1. This 100 is initial assumption. We will use design spec to find steam flow rate. The goal is, look at this, cold stream outlet vapor pressure. How do I know it's 0.872059? Inciting condenser reboiler, you need to get it from the column, column 1. Under configuration, condenser curve, reboiler curve. So you look at the reboiler curve. Result. Bottom liquid leaving state 34, going to state 35, temperature increase from 52 to 58. Coming out the reboiler is not fully saturated vapor, 87.2059% vapor. That is what you use to size the reboiler. So you look at the flow sheet, reboiler, 87.72059. That's called from reboiler curve. For condenser curve, typically, hot stream outlet vapor pressure 0, not that complicated. For reboiler, cold stream outlet vapor pressure may not be 1 fully vapor. You need to check reboiler curve. And you use a design spec. Coming out temperature fully, coming out the reboiler temperature, you vary LP steam flow rate. So that you can follow the instruction simulation example. Now, look at today's handout. As part of your 2-page memo, there are 2 crucial tables to demonstrate your answer. Heat exchanger. In this memo is before integration. Utility cost, annual cost, use 8,000 hours per year. Okay? Equipment after integration, that's the next memo, not this one. So, you need to know total annual cost before integration. You notice one thing? Total utility cost for heat exchanger, very small. Even after heat integration, your cost saving is minimum $1,400. But you look at column 1 condenser, reboiler, column 2 condenser, reboiler. And you can integrate column 2 condenser, column 1 reboiler. I'll teach you early next week how to do it using pseudo stream. Total annual cost, $8,000 per year. Before heat integration, $268,000. After integration, $195,000. Total annual cost savings, $72,000. I want you to show the number percent reduction later on. So, for this memo, you do not have the cost after integration, but you have the base number before integration. That is part of this memo. Now, that is for this first handout. For Friday, problem is simple. Between now and Friday, 2:30 p.m., when you review your heat integration, you get confused, you got any question, drop by my office. I can go over some solution, explain to you the logic. I did that for about 15 students so far. So tomorrow, even today, this afternoon, I'll be here till 6:30. Tomorrow late in the morning, all day. You need help to understand how to match process stream, how to analyze everything better. Just feel free to drop by. Okay? That is all for today. Any questions?